Good afternoon, everyone, and welcome to the second installment of Galco's What Drives Our Industry webinar series in partnership with ABB. My name is Charlie Cooper, and I will be your moderator for today's session, where we will be talking about the flexibility, efficiency, and availability of AC and DC drives, new and important industry and drive technology trends, and how Galco and ABB are working together to help our customers overcome supply chain issues, because we all know this continues to be an issue. Before we get started, I'd like to introduce today's panel of experts. First, we have Michael Herman, Regional Strategic Sales Manager with ABB. Michael has over 30 years of drives and automation industry experience in engineering, sales, and sales management capacities. In his current role at ABB, he is responsible for growing ABB's market share of products and packaged solutions in the high-power performance product platform through current and prospective customers. He also acts as lead on large projects and pursuits aligned with the overall growth strategy of the System Drives Group. Next, we have Jeff Vornhagen, Regional Sales Engineer for the Detroit region with ABB. With over 30 years of experience in sales and sales support for automation products, including PLCs, HMIs, VFDs, and servo drive systems at the high-tech authorized distributor and manufacturer level. Jeff brings a wealth of knowledge to today's webinar. Finally, we have Galco's own Technical Support Manager, Randy Barbrett. Randy has been a valued member of the Galco team for over 25 years. Starting off as a field service technician, from there he advanced to a repair service manager before landing his current position as a technical support manager. As a technical support manager, Randy is instrumental in assisting customers by helping them find the right component for their job or project, troubleshooting products to ensure efficient business solutions, and providing cross-referencing solutions for hard-to-find parts. Welcome, gentlemen. Now that we have the introductions out of the way, let's go ahead and jump into the panel discussion portion of today's session, starting with a review of current trends in drive technology and the industry. As technology progresses in the industrial automation and electrical distribution industries, there is an emphasis more than ever on IoT products and how parts and applications can be synced together through a singular interface or product. Michael, can you share more about how the research ABB has been doing on digitalization, sustainability, and the role of industrial IoT is essential to achieving sustainability goals?
So as ABB, we're looking at that as the next trend in the marketplace. I think analytics and information are crucial for anybody that gets into the automation sector, and how you get that information back to customers and users that can take advantage of that tool.
So what is ABB doing to not only have products in the IoT space, but innovate when it comes to communication protocols? Jeff, let's have you kick this one off.
Yeah, we have an entire product line dedicated to the IoT and to digitalization. It's called ABB Ability. And so we put tremendous resources into creating new products and into making sure that we keep online with the current trends in communications, protocols. So we have a product, for instance, called the drivetrain, digital drivetrain, where we can do digital drivetrain condition monitoring, via the internet through collection of data on components of a drivetrain, which would be sort of drive, motor, and say pump, with sensors and obviously the information that we have readily available through the drive, since we have that set up for the IoT, so communications. And with that, you can do all sorts of predictive maintenance, energy monitoring, with very standard and cutting edge, for that matter, communication protocols such as MQTT, through OPC UA, and I'm throwing the alphabet soup at you here. So, but these are common communications file transfer and data format protocols that are being used via the IoT. We have, through drives, a device called a NIDA 21, device that is a web-enabled device where we can serve up web pages with all the information related to the drive. So these are just a few things that this group with ABB Ability is doing on behalf of this this new frontier, so to speak. So
great.
It's a lot going on.
Great. And Michael, was there anything else you add about that?
This is just another trend that we have in the AC drive market. If you look at it historically, we've gone from understanding how to control an AC motor and enhancing that with the available processors that we have and the speed they can do things. And then safety became a very big important feature of that next step, which is how to protect people and machinery in an environment where they could possibly get injured if they do something that could be dangerous. This is a new emerging market. We're all kind of grasping on it. There should be more to come. Obviously, you can take your existing product platform and figure out how to get this IoT developed, but the next technology will enhance that even further.
So Jeff, can ABB drives communicate and operate on Ethernet and IP networks?
Absolutely, and we do it pretty well. We basically support all standard industrial Ethernet protocols across the board. Two of the most popular ones are Ethernet IP, and the new emerging one, just in terms of usage, is EtherCAT. And so we have a dedicated website, or what we call our connectivity website, that has all resource materials for Ethernet IP, including these things called add-on instructions, which is code that has been pre-written to connect our drives to certain types of control platforms. And so that's the amount of resources and effort that we put into supporting Ethernet type protocols. We support Modbus TCP, for instance, Profinet, and these are all pretty much the standard global Ethernet protocols that in industrial environment that people are using. And I just want to make the statement, don't let anyone tell you that ABB drives cannot communicate over Ethernet IP, because that's absolutely not true. So
it's safe to say that ABB drives are pretty compatible with other brands out there.
Absolutely, yeah. We can connect to anybody else's basically control platform. We don't have to connect ABB drives to ABB control platforms. We can can put our drives onto basically anybody's control platform with all the standard communications protocols. So.
Great, thanks. Now let's dive a little deeper into the drives and their functionality, as well as their efficiency and flexibility. First, what are some distinguishing features of ABB drives? Michael?
So if you look at the evolution of the AC drive, it was primarily done for energy savings initially. So there's a lot of functionality behind the scenes that help with applications where we can help a customer gain efficiency through their process control and so forth. Today's drive, certainly there's a lot of functionality based into it. Now we have onboard safety functionality. So you have a safe torque off circuit that can be integrated into a safety system, give the customer that more reliability in their system that they're going to protect their employees should they get into a dangerous situation. Other than that, we have a lot of embedded functionality just for motor control. So think about applications. An application where a VFD can be applied today could be a winder application in a steel or paper mill. It could be a crane application in an industrial facility. There are now functionality embedded in there to help manage that type of situation. A good example is a crane. You want to control that that crane control, and it's got a load hanging on there. We can now manage the sway function in that application. So there's a lot of type of application-specific things that the drives can do, whether it's built into the product or it's added onto the product.
So Jeff, can you share with our audience a little bit about what a VFD is and how it works?
Yeah, and that's a very basic question, and I've done a lot of training in my career, and a lot of times I have to, right at the beginning of the training session, I certainly have to ask that question. Do people even know what a VFD is? So, but basically VFD is a power electronics device that controls the speed of a motor. That's it, very basically. It consists of three main parts. There's a rectifier AC to DC converter front end, a DC bus intermediate circuit, which has a capacitor that kind of hold the electrons until we're ready to massage them through our inverter or IGBT output, okay? So what that does, the IGBT output, is it creates a simulated AC waveform where we now control the frequency of the back and forth of that AC waveform. Now, why is that important? Because you control the frequency of a motor, that's how you control its speed. So basically how a VFD works. So.
Great. So Randy, how would you size and select a VFD?
Typically I talk to the customer and see what their application requirements are, whether they need to do any kind of feedback, need to have any kind of braking systems in there, what is the actual motor specifications as far as voltage, current ratings, what kind of I/O requirements they have, communication requirements they need. The drive is going to be inside an enclosure, they're going to be mounted on a wall, so we need to know what kind of enclosure requirements they have. So a lot of little things like that you got to find out ahead of time before you can just say, here's a drive.
Thanks, Randy. Jeff, would you like to elaborate on any of that?
There's very basic information you need to size a drive. Okay, you need to know the voltage, you need to know of the power supply, number of phases of the power supply. You need to know the horsepower of the motor that it's going to operate. But more importantly, you need to know the full load amps of the motor that the drive will operate, because it's all about amperage. Okay, so basically the point that Randy made, that application information is critical. Okay, you always need to know what the application is, because it will definitely impact the sizing of the drive. Okay, for variable torque or normal duty application, we're going to size the drive one way. For a heavy duty application, which is usually constant torque or high overload, we're going to size the drive a different way. That's going to impact the price. So other consideration is what kind of environment are you going to install the drive in. So you need to know what kind of NEMA rating for the enclosure. You know, is it going to be in a nice clean control room, or are you going to nail it onto grandpa's tree in the back 40 and it's going to be in the rain and the sleet and the snow? So these are all critical pieces of information that we can't go forward with without this data in order to size a drive. So other considerations are, or do we need to support a certain kind of communications protocol, such as Ethernet IP or EtherCAT? There are other considerations, such as harsh environments like extreme temperatures or high altitude that might also impact the sizing of the drive. So, but I think we've hit along the very basic types of information we need in order to go forward, help the customer.
Michael, was there anything else to add?
I think, they make great points here. I think at the end of the day, more information we have, we can select the right drive. There is a multitude of products out there. Each has their own application capability and functionality. So the more information we have about the opportunity, the better selection we can give and optimize it for the customer.
So Jeff, can ABB drives operate as phase converters?
Absolutely, yeah. That's a very common application where you can take single-phase power in and convert it to three-phase. The only consideration is the drive has to be oversized. Now, a lot of times we do that work for you, and we just basically market single-phase drives. And so we've already done that work for you as far as oversizing the drive. So that's a very good application for people who basically only have single-phase available. Some agricultural applications only have single-phase available to them. So they can take in single-phase, output three-phase, and operate a three-phase motor, because a lot of standard motors are three-phase, and so that's a very easy thing for a drive to do.
Thanks, Jeff. Now, Randy, when should someone consider replacing their old drive?
Typically, if you start having issues with it, getting nuisance trips, and it's up there in age, say 15, 20 years old, you got to start looking at the characteristics of what's going on and the environment around it. If you got a very hot environment, they don't last as long. Dirty environments, they don't last as long. And you start getting issues going on with some miscellaneous faults coming up that really aren't true faults. And at that time, it's probably good to look at replacing it, getting an upgrade done to it. In which case, then we want to know, basically like you would any VFD application, what are the basics behind it, the applications, etc. I always like to look at the old drive to see what its functionality was, and if the customer has interconnect diagrams, I can make sure I get all the I/O requirements met, so that we don't have any issues with having to add any options later on.
Great. Michael, Jeff, anything to add?
So I think a big thing you see in the industry is life cycle of products, right? So as products become aged, they certainly reduce life, but there's also a support functionality behind it, which is where the manufacturer may no longer be able to support parts and pieces to either maintain or repair that drive. So that's another factor why customers go through this replacement decision.
Now that we've talked about drive functionality, let's discuss how using drives can help reduce energy use and lead to cost savings. Jeff, what are some drive applications where customers would see energy savings and a better return on their investment?
So substantial energy savings can be gained with centrifugal pumps and fans, which there are quite a substantial amount of installed pumps and fans throughout the global environment here. So when you talk about efficiency with centrifugal fans and pumps, you're talking about a thing called affinity laws. Basically, there's a cubed relationship between the speed of a fan or pump and the power consumption, okay? And so what this means, as an example, if I were to reduce the speed of a centrifugal fan or pump by 10%, I would realize almost a 25% savings in energy usage, and that is huge. So wherever you have any kind of application, and a lot of them are related to HVAC and water, wastewater, and you have a pump or a fan without a drive on it, you're just throwing money away. The return on investment on that kind of adding a drive to a centrifugal fan or pump are tremendous, and so you'll basically get your money back by doing something like that. And so, you know, in many other instances, if you can reduce the speed of any kind of a motor in any kind of process, you're going to gain energy savings generally. So, you know, that's as I think the comment was made earlier, the original idea of using a drive was for energy efficiency. Creating the drive itself was for energy efficiency. So, because otherwise all motors basically operate across the line, very inefficient, and mechanical means are used to restrict flow, say of water or air or process flow, okay? So now you take out that mechanical mean, very inefficient, and you replace it with a drive. Now you just slow the motor down to the proper operating speed that you need, and you're just saving tremendous amounts of energy. So.
Besides energy savings, what other cost savings comes with the benefit of the drive?
Great question, Charlie. So besides energy savings, we have a lot of other benefits that a drive can help and enhance the performance of an application. Think about your across-the-line started motor. Every time we start that motor, there's a huge impact on the electrical system, and there's also a huge impact on the mechanical system. So by putting a VFD on there where we can ramp up that control and manage the torque to the motor, we can put less stress on your mechanical system, which hopefully should extend the life of those mechanical components. Also put less demand on your power system. Those are huge benefits, right? Then if you think about your actual process control, a VFD can add both acceleration control and deceleration control. So that can enhance where we need to start and stop an application repeatedly and get it precise with the process control.
And Michael, do you have any industry-specific examples, say in food and beverage, agriculture, or packaging and processing, where energy savings were realized?
There's you know, a great example. That industry as a whole has a large installed base of centrifugal pumps and or fans. So everyone could potentially pose an opportunity. So the big thing is to understand, are they being run as a constant speed application today? And as Jeff mentioned, are they controlling a process externally? It could be a valve on a pump. It could be a damper on a fan. All of those present opportunities for us to go in and analyze. There's plenty of tools out there to help the customer determine if there is going to be a return by putting a variable speed control drive on that application. But the idea is to take the opportunity and look at that application to garnish to see if that's something feasible to move forward based on whatever their economic conditions may be.
That's great, and I'm sure we have some people watching today within those industries too. Now, Jeff, what about torque? What's the difference between constant torque and variable torque applications?
It's pretty easy. Centrifugal fans and pumps are variable torque. Pretty much all other applications are generally constant torque, and that means that whether you're going at a low speed or a high speed, your torque requirements are basically the same across the board. Now with a variable torque application, if you're operating at a slow speed, your torque requirements are lower. And that's how you get some of those energy savings I already mentioned related to centrifugal fans or pumps. So with that, these are critical components of the decision making for which drive we're going to select for an application. Because variable torque applications generally don't need as high an amperage rating for the drive, so we can sell you a more inexpensive drive. And also has to do with a thing called overload, whereby when you start a particular process or a mechanical process, generally you need extra torque say, break away from some kind of a standing load or something. And so that's another consideration when sizing the drive, that constant torque applications can often be high overload, okay? Whereas variable torque applications generally can be low overload, so you don't need as much current to start, so you can use a smaller drive. So.
Great. Michael, why would someone use DTC?
So DTC is direct torque control. It is an algorithm that we use inside our high performance drives. It goes back to the 1990s. It's into third and fourth generation products today. Slightly different than say a traditional vector drive. But the advantage of DTC is when speed regulation is a requirement, this gives us the ability to do open loop control and manage the flux and the torque to the motor, and then obviously manage the speed to the motor. If we put an encoder on there to close the loop, that obviously becomes very tight speed regulation. Other things that DTC gives us an advantage to, it can help in starting applications, so you could have a large load that needs to start under a very fast rate or something like that. DTC can be predominant part of that control. Other great applications is web-based processes. So anything that's got a web to it, we will traditionally use a DTC-based product, which today's product is our ACS 880.
Thank you for that insight. Now, let's shift a bit and address the topic of ongoing supply chain issues, because we all know that this continues to be problematic in our industry. A persistent issue that customers and businesses face when it comes to lead times and part availability is having to seek out maintenance to prolong the life of their existing products. But at a certain point, parts become obsolete. How is ABB taking steps to develop new drive offerings with ease of use in mind, but also help with future maintenance costs?
So you're going to see inside of drives a lot more functionality to help with predictive maintenance, right? And we mentioned before the IoT. So if you look at behind the scenes what this IoT presents, it gives us the ability to take analytics and data about that drive, push it up into a platform, whether it's a distributor or our own factory resources. We can help customers assess their product and give a perceptive of what that product is doing. It can help with identifying preliminary issues. If it's a critical process, instead of being reactive until the product breaks, we can be more proactive to say, hey, we're seeing a reduction in this process. This might be the issue. It could be driver related, it could be externally rated, but those are all functionality. So there's a lot of features we can put in the product to be more proactive about maintenance and not get into the situation where we're down and it's a reactive model to say, I need this replacement or I need this part.
Great. Jeff, anything to add?
Yeah, this goes back to the Internet of Things and how we can pull all sorts of data from not only the drive, but the drive train in order for us to monitor all sorts of things and do predictive maintenance, and also analyze energy usage. And with predictive maintenance, you're going to avoid maybe a plant shutdown for that matter. I mean, these are all things that go back to this concept of sustainability that I think was thrown out at some point here. So we have all the tools available to extract data, but we have even more tools to analyze data and help customers that way, and to basically help them manage their process in the most efficient way and to basically keep running.
Thanks, Jeff. For those in the audience who attended the first session, Supply Chain Disruptions and Cross-Referencing Solutions, we elaborated on how our cross-referencing process works when it comes to finding reliable and comparable parts. With that being said, Randy, what kind of information is needed for cross-referencing drives?
Basically, as if it's a new application, you really need to know everything. No two drives are the same. Each one's got some unique characteristics to it. So sometimes we need to know, do you need those particular functionality in your application so that anything we replace with it will work for you. So basically I look at it as a brand new application and I need all the basic information, applications, I/O requirements, communications, motor FLA, motor data, and start from there.
So Randy, regarding the sizing of a drive, can you explain a little further?
Again, trying to cross drives, if you don't have the motor information, it's like, well, this drive is worth 20 amps, so this one's, I got to have at least 20 or maybe 25 amps in the next brand, when really the motor's not that big. So by having the actual motor data off the nameplate, we know exactly how many amps you need for that particular application, whether it be a constant torque or a variable torque application. Yeah, otherwise, you're oversizing everything to make sure you got yourself covered. which in some cases can lead to a physically bigger drive that may not fit in the particular space they got to work with, or excessive cost. So that's why it's a good idea to start from the beginning and say, give me your motor nameplate data so I know exactly what you need for and what your application is, so I can size it according to that, instead of trying to go off an old drive that could have been oversized to begin with, and now making it even larger than that and making excessive costs to the customer that's not required.
Thanks, Randy. Now for the ABB side of things. Michael, what tips can you provide to our webinar attendees when it comes to finding another solution by upsizing their drive or finding a different model or series to fit their application?
So I think that's key in the discussion, as Randy indicated, to have much more information about the application and the opportunity. If you're looking at a replacement or an upgrade, there are going to be situations where what was provided before may have been the solution available at that time. It can be undersized, it can be too much performance there. We have products today, general purpose products that go up to 700 horsepower. If that's an application where that's the right product for the right solution, we want to use that when and where appropriate. Obviously, if we know more about the application and the opportunity, we can help select the right product for that situation and minimize the potential issues down the road.
Perfect. Jeff, anything else you'd like to recommend?
We have a very broad product offering, and so yeah, a lot of times we might be able to substitute another product for one that is not readily available. And we mentioned, upsizing drives. Maybe a higher horsepower drive is more available than a lower horsepower drive. You can always use a higher horsepower drive with some rules of thumb for a lower horsepower motor. So these are some of the tricks of the trade, so to speak, for us to try and get through the supply chain issue, as we try and take care of our customers as best we can.
In addition to cross-referencing, we've also touched on how Galco's customer service representatives and trained technical experts can be of assistance. So I'd like to take this opportunity to expand on that a little bit more. Randy, can you share more with our attendees regarding the value Galco brings to the table?
Well, one of the things that kind of makes us as a unique distributor is the fact that not only do we sell drives, but we also have a repair department. We can repair drives. We've had people that go out and actually do the installs and startups of drives. A lot of distributors don't have that kind of people available to them in their technical side. So myself personally, being out there in the field many years, I can offer a lot of technical support over the phone to customers after the installation or troubleshooting. It kind of makes us very unique, I think, in this industry.
In addition to calling in to speak with one of our technical experts, where else can customers go to obtain additional information about ABB and Galco drives?
Actually, go to Galco's website, you look up your part number, and under documentation, we usually have the catalogs, the user's manuals, the software manuals, the hardware manuals associated with those drives. Other than that, you can go to ABB's website, plenty of information there also.
Yeah, ABB side of things, how would someone go about?
Similar thing, go to our website, www.abb.com, select drives under products, go barrel down. If you're looking for DC information, AC, we have it by the product groups, and then you can narrow down whether you're looking for product specific things. There is a lot of information there related to field bus connectivity, all kinds of information. So it's a pretty broad spectrum, but there's a lot of detail there. You just got to sort through it.
Great. Thanks again, gentlemen, for sharing your expertise. Now it's time to move on to the live Q&A portion of this session, and we do have some questions that came in from our audience, so let's get started. Okay, let's see. Our first question: What ABB products are your main push in the coming year, and what is phasing out? Jeff?
Basically, we are moving forward with a kind of a philosophy or approach to drives referred to as all compatible drives. What we're trying to do is have a drive family that will have a sort of a common platform, which would include the same configuration software, a common interface, and a common parameter set, among other things, across all product lines. So these are referred to as our 80 series drives. So we're definitely promoting those. We're definitely encouraging people to migrate toward those. And those would include the ACS 380, which is a micro drive. And we have the ACS 580, which is a general purpose drive for both variable torque and constant torque applications, and has a much broader horsepower range. And finally, our high-end ACS 880 industrial drive, which includes direct torque control and goes into thousands of horsepower in terms of its horsepower range. So anything with an 80 on it is kind of what we're suggesting that people look at currently. In addition, though, because of the supply chain issues, we're continuing to manufacture and support another micro drive series called the ACS 355. And again, the intention is to provide as much product on the micro level, which is where a lot of the supply chain issues are occurring. So those are kind of what's going on, what we have presently. So drives that are being phased out would be the ACS 550 and the ACS 800 at this time. But just to reassure everyone in the audience here, we continue to support these drives for an extended period of time through our drive services group. And we do that by providing spare parts and repair services, as well as our technical support line, continuing to have a knowledge base for those products. So you call into tech support and they can continue to assist customers with these so-called legacy drives or drives that are obsolete. We also continue to maintain documentation on our website for all of these drives that are in the obsolete phase or so-called legacy drives. So,
great. Okay, next question. Randy, this one's for you. What are harmonics, and are they something to be concerned about?
Harmonics, there's a phenomenon with VFDs that they produce harmonic current imbalances that can cause issues to other equipment nearby on the grid. It could cause nuisance circuit breaker trippings that are bad enough, overheating of transformers in some instances. So they can be a concern. They could cause issues with especially sensitive type of equipment. This is particularly important inside very technical installations such as water treatment plants where they have a lot of monitoring equipment going on, or in hospitals where they have a lot of technical equipment there that are very sensitive. They want to make sure that there's nothing that can cause any issues with the caused by the generation of harmonics.
Great. Next question, Jeff, why do drives have dual ratings?
Yeah, drives have dual ratings because there's basically different groups of applications. And in order to get the most cost-effective solution to these different applications, we have dual ratings in terms of horsepower and current ratings for an identical model number. Now, we've already discussed this idea of variable torque versus constant torque, and so that would apply. A variable torque drive only needs a certain amount of what's referred to as overload or starting torque. So generally, it's 110% of the rating, the current rating of the drives. A constant torque, and especially a heavy overload application, which may be, say, a conveyor that's fully loaded and has to have quite a bit of extra torque to start, so-called breakaway torque, to start that load, would have a different, would go to a heavy-duty rating of a drive, which would provide 150% current, short-term current availability in order to break that that load from basically a standing stop. So that is our way to basically give you a cost-effective approach to these applications. So one drive, which could be a lower horsepower, less costly drive, could be used for a variable torque application because it just doesn't need the extra current. And for a heavier duty application, high overload, then the drive would have a lower horsepower rating. And so therefore, they would add that, provide that extra current, short-term current. And so in a sense, you'll have a drive that will have two ratings. You could have a drive that would have a 5 horsepower heavy duty rating and a 7.5 horsepower light duty or normal duty rating. And for, again, variable torque applications. And just to remind you, variable torque applications are generally centrifugal fans and pumps. So that's why we have dual ratings for drives.
Great. Randy, this next one's for you. Regarding overload ratings, how do they relate to applications?
As Jeff kind of explained right there, that the overload has to do with how much torque you need to break away your load from a dead stop. In classic examples, always the conveyor. You got a conveyor that's loaded up with a lot of material on there. It's got a lot of weight to it. And as soon as you start to move that conveyor 1 inch, you're moving all that weight. So you need a lot of breakaway torque to get it started. Whereas a centrifugal fan or centrifugal pump, when you first start out, don't move much of either air or water until you get up to a certain amount of speed. So they don't need a whole lot of breakaway torque available to them to get the whole thing started. So that's where you get the dual ratings of the constant torque versus variable torque.
Great. Next question, Jeff, can you upgrade from an AllenBradley VFD to an ABB VFD?
Oh, absolutely, no problem there. And you know, I think we've already alluded to the fact that we fully support Ethernet IP, which is a very common field bus that's associated with Rockwell control platforms. So generally, we're going back to considerations as to how you size a drive, first of all. So you would look at the existing AllenBradley application and you would assess what that application is and what the specifications of the existing drive are. And that can be gained from getting the model number of the AllenBradley drive and just making sure that considerations such as adequate amperage is provided by the replacement drive at the designated supply voltage. Any other features that might be associated with the AllenBradley drive, such as safe torque off, safety. But I certainly can't emphasize the idea, though, that the ABB drive can communicate on the existing AllenBradley communications network. And we have tools to assist with that. And again, especially with Ethernet IP. We have a dedicated website for tools and resources for Ethernet IP communications, including little bits of code that are written in Rockwell RS Logic's language that we've already written for you, which you can drop into an AllenBradley program, and then you will thereafter be able to very easily recognize the ABB drive within the network. And in addition, pass all sorts of pertinent information related to the drive and how it's operating on the network. So very, very easy to replace, upgrade an AllenBradley drive with an ABB drive.
Great, thanks. Now, Jeff, staying with you, can you provide some tips and best practices for troubleshooting VFDs?
Yeah, it's very early on when I started to deal with VFDs, people would give me, would call me up and basically say, I installed your VFD and I've got it all wired up and energized, and I can see the keypad is energized and it looks like it's operating, and this thing just won't even spin this motor. So very basic things with drive and troubleshooting. Drives need two things. They need basically a start command to tell it to start, and it needs a speed reference. So first of all, you have to say, okay, drive, I want you to start, number one. But then you got to tell it, well, how fast to go. So lot of times what I find is that either the start command is missing, either it could be via hardwire communications or through field bus communications, or you may be getting start command and no one has told the drive, no one meaning a PLC or a hardwire analog signal, no one has told the drive how fast to go. So it basically is going to sit there and say, well, I'm just going to be at 0 speed. And so it would appear as if there's something wrong with the drive. So those are two very basic troubleshooting tips. So our drives have all sorts of fault codes. So as you try to operate the drive and commission it, there are all sorts of indications in the keypad to kind of point you in the right direction if something has gone wrong. So let's say you have, say, an overcurrent situation, which is very, very common. And it could be that you simply have too fast of an acceleration programmed in the drive. The drive is attempting to accelerate a load much too quickly, and it could be a very heavy load, in which case it would exceed that 150% overload that I mentioned earlier. So that's something to look at as well, as far as your acceleration rate. There's many, many other tips that are indicated by going to a lookup table associated with a fault code that you see. So sometimes you have, for instance, another very common occurrence is that the DC bus voltage is too high. That could occur from what's called regeneration. So it could be that there's something occurring with the load whereby the motor begins to act as a generator and sends current back to the drive. And one indication of that would be a DC bus voltage being high, in which case you might have to look at the mechanical portion of the application to see if there's any mechanical bounding, or if perhaps you need to consider using a braking resistor or a regenerative drive. So many, many, many things could happen when you're commissioning a drive or have a drive that's in operation. But the best news is that the drive itself is going to try and tell you what's wrong and point you in the right direction as far as both diagnostics and potential solution.
Great. Those are good tips. Thank you, Jeff. All right, our next question is for Randy. How do you size conductors and overcurrent for drives?
As far as the conductor goes, I always recommend looking at the manual. Every drive manufacturer in their manual usually has recommended conductor size based on the lug that they're attaching the wire to, so they know what the maximum size conductor that can be put onto that device. So I always tell the customer to reference the manual itself to see what the OEM recommends. In this case, ABB's manuals are very good in the technical support, and during the electrical installation portion of it, it'll tell you what size conductor to use. As far as the overcurrent drives, I believe what they're referring to is the overloading capability for the different types of loads. That's the only thing when you say overcurrent, I'm assuming you're referring to, which we talked about, the variable torque versus constant torque ratings. If you have a good heavy duty application that requires 150% overload, then you definitely got to use the constant torque ratings. If you're using a normal duty or light duty type of application, such as a centrifugal fan or a pump, then you can get away with the lighter duty 110% overloads.
Great. Okay, one more question here. I'm located outside of the United States and need to place an order. Is that easy to do, and will you ship internationally? First, yes, we do offer international shipping on our products, and you can easily do that on our website at www.galco.com. When you add a product to your cart and proceed to checkout, your displayed price will reflect the all-in cost with taxes, duties, and shipping included in the currency that is used in your country.
That That's all the time we have for today's webinar. Mike, Jeff, Randy, thank you for coming in and sharing your expertise with our attendees today. And I'd also like to thank everyone for joining. Just like our previous webinar, if we didn't have a chance to answer your pre-submitted question, one of our in-house experts will be contacting you directly to provide you with additional information. You can also visit us at www.galco.com to view and order products discussed in this webinar, or call us at 1-800-575-5562. Have a good one.